So today we're going to learn a new integration technique. So far all we've learned is the power rule and U substitution. This one is called integration by parts, and where it actually comes from is the product rule. So you can think of this as a reverse product rule. Remember, the product rule is the derivative of uv is u times dv dx plus v times du dx. Now what happens if I integrate both sides of this equation? And don't forget, I need to put a dx in order to integrate. What you end up with is the derivative and integral cancel, so you get uv is equal to the integral of u dv, because the dx's cancel, plus the integral of v du, because the dx's cancel. So what I'm going to do is I'm going to move this part of the equation over to the other side, and we'll get our integration by parts formula, which is u dv is equal to uv minus the integral of v du. So this is what we're going to use, and for the first example, I'll take you through the steps because this is the first time we're trying it. So for this first one, let's try the following integral. Integral of x e to the 4x dx. So what I need to start thinking about is I need to make a choice as to what is going to be my u in this case, and whatever is left over, that's going to be my dv. So for this first example, I'm going to let u be x. Then dv is what's left over, which is e to the 4x dx. So if I crank it into the formula, I first need to find du dx, which is just 1. And if I move the dx over, I get du is equal to dx. And on the other side, if I integrate dv, I get v is equal to 1/4 e to the 4x. So we're all set to plug everything into the equation as needed. So if we take a look at it, the first part is u times v, u times v. So let's go ahead and write that down. So our u was x, our v was 1/4 e to the 4x minus the integral of v du. So the v again was 1/4 e to the 4x, and our du is just dx. If you do this correctly, the integral should be pretty easy to integrate. So now we can integrate that as negative 1/16 e to the 4x plus c. So the final answer is that the integral of x e to the 4x dx is 1/4 x e to the 4x minus 1/16 e to the 4x plus c. One of the things we need to start thinking about is how do you choose your u wisely? So here's a situation where maybe it's not clear whether it's the x squared or the natural log of x that we should choose for u. Well, Wikipedia came up with this great acronym, and they call it ILATE. The I stands for inverse trig. So the first thing you want to look for, is there an inverse trig function? The L stands for logs. You want to see if there's a log, and we can see there's a natural log in this problem. The A stands for algebraic. Algebraic functions are things like x squared, x cubed, anything of that sort. The T stands for trig, and the E stands for exponential. E to the x, things like that. So right away here we can see that we should choose u to be log, because that's what comes first in ILATE. So du dx is just 1/x, and if I move the dx over, du is 1/x dx. So by default, all that's left over is the x squared dx, so that has to be my dv. Notice that dv has to be integrable, and you can integrate that as 1/3 x cubed. So now we're ready to plug everything into the formula. So here we go. I'm going to write down u times v, which is natural log of x, times 1/3 x cubed, minus the integral of v du, which is 1/3 x cubed, and then the du is just 1/x dx. Let's take a look at this integral. If I simplify that, it's just negative the integral of 1/3 x squared dx, and that's very simple to integrate, so I know that I probably made the right choices. So the final answer is 1/3 natural log of x times x cubed minus, and the result of that integral should be 1/9 x to the 3rd power plus c. Here's something you've all been dying to know. What is the integral of natural log? So by I late, I'm going to choose u to be ln of x. Du, as we saw before, is 1 over x dx. dv is what's left over. Well, what's left over? It's really dx. So we can write dv as 1 dx if you feel more comfortable with that. So when we integrate it, v is equal to x. Plugging it into the integration by parts formula, I'll get ln of x for u. V is just x, minus the integral of v du, which is x times 1 over x dx. So what we have is x, natural log of x, minus the integral, if I simplify that, of 1 dx. So what we learn is that the integral of natural log of x dx is x times natural log of x minus, and that integral is x plus c. And there you have it. Now you know the integral of natural log. Here's a slightly tricky example, integral of x e to the x squared. So if you go through I late, you might think that the best choice for u would naturally be x. So if I let u be x, du is just 1, so du is just dx. And what's left over is that v has to be e to the x squared dx. The problem with that is, try as you may, you cannot integrate e to the x squared. If you think you can, you have some issues. Instead, this problem is actually a u substitution. It's not an integration by parts. So what we need to do instead is choose an appropriate u to solve this problem. Without too much thinking, u equals x squared is probably the best choice. So du equals 2x, and if we solve for that, dx is du over 2x. Plugging everything in u land, you end up with 1/2 the integral of e to the u du, and you can integrate that all day, and that turns out to be 1/2 e to the x squared plus c. So the moral of the story is, not everything is integration by parts. You always want to start with u substitution first. Let's take a look at this example. Using I late, we're going to let u be x squared, and so du dx is 2x, so I move the dx, du is 2x dx. By default, dv is what's left over, which is sine of 2x dx, and when you integrate that, you get negative 1/2 cosine of 2x. So if you plug it into the formula, you get x squared as u, and then negative 1/2 cosine of 2x, minus the integral of v du, which is minus 1/2 cosine of 2x, and then du is 2x dx. Again, we want to take a look at the integral and see if we can go ahead and integrate that. The problem is, it's actually not that easy. So if I simplify this, I get the integral of x cosine of 2x dx. Guess what? It's another integration by parts. I'm going to choose u to be x, du to be 1 then, so du is dx, dv is cosine of 2x, and what I end up with for v is negative or positive 1/2 sine of 2x. Plugging that into the formula, just for the integral, you'll get x times 1/2 sine of 2x minus the integral of 1/2 sine of 2x, and our du was dx. So this entire problem took integration by parts twice, and if I simplify it, I get 1/2 x cubed cosine of 2x, and the integral part looks like this, plus 1/2 x sine of 2x, and then another plus 1/4 if you do the integral cosine of 2x plus c. There must be an easier way. It turns out there is. It's called tabular. We're going to do the same thing, except for we're going to take derivatives until we're down to 0. Then on the other side, whatever dv is, we're going to take integrals until we match up. So here are the integrals of sine of 2x. The first one is negative 1/2 cosine of 2x, negative 1/4 sine of 2x, and then lastly 1/8 cosine of 2x, and we've matched up. Then we're going to take these and multiply diagonally. The only thing you have to watch out for is the SIGNs are going to alternate. If you're wondering why this works, you want to take a look at the last problem and see the connections, because this is really the same thing. So what you end up with, if you multiply, is you end up with negative 1/2 x squared cosine of 2x, and then the minus minus creates a plus. The 2 and the 1/4 cancel, so you get 1/2 x sine of 2x, And finally, the 2 to the 1/8 give you plus 1/4 cosine of 2x plus c, which is exactly the same answer as before. Let's revisit the problem of the integral of natural log. So I already have it all set up. But what happens when I have bounds? Where do the bounds go? It turns out the bounds have to go for both parts of integration by parts, because a definite integral you need to plug in to the entire answer. So the first part is 2 natural log of 2 minus 1 natural log of 1, and then that integral is just x from 2 to 1, and you can figure it out from there. In terms of just a few last remarks, keep in mind u sub is what you always want to try first before you try integration by parts. Secondly, if you do have a definite integral, as we saw in example 7, you have to plug in the bounds to the entire answer, not just the part with the integral of b du. You also have to plug the bounds into the uv portion of the integration by parts. Thirdly, a word on tabular. Tabular integration only works in certain cases. It only works specifically if the u you choose will eventually go away when you differentiate and become 0. If I choose e to the x as my u, that's never going to become 0, in which case tabular won't work in that situation. So tabular does not always work, and sometimes you just have to do things the long way. I hope you enjoy. Make sure you do your homework.